Hey guys, welcome to question 10. So this question is pretty simple. It says given a data set consisting of only three samples, 1, 2, and 5, and the sigma 1, what is the p of x according to KDE? If you guys remember, I don't know how to write this, KDE method uh, says that a p of x, the estimated probability density function of a distribution, is just the average of a bunch of Gaussians parameterized by the samples we have. So that kind of seems a little abstract. So let's just say p of x given, um, this is going to be a little confusing, but big X, comma, sigma is equal to the sum. So it's the sum from I to n, where n is the number of samples in big X of the probability I. So I'm just going to say this pi, this is like the ith Gaussian. This is a little confusing because of two p's, but maybe I'll call this g. So g just means the PDF of a Gaussian, and this takes in that x value, but instead of it taking in mu and sigma, mu is going to be the ith sample in x, big X once again, and then its sigma value is just going to be sigma. So we sum a bunch of Gaussians together and then we average it by the number of samples. So this is our KDE estimate. So I'm just going to pop something in here real quick. So if you remember correctly, the Gaussian distribution PDF is defined as, so I'm going to change this to G just to be consistent. So in this case, it takes in a mu and a sigma. If you look back up here at our equation, that mu is the xi. Sweet. So now that we have all this set up, and I apologize for the weird notation, but we know that x is equal to 1, 2, and 5, and sigma is equal to 1. So I could write this out 3 times. I'm not. I'm just going to call it g, and then whenever I'm giving it a mu value, I'll just replace this mu with that value, and then I'll replace this sigma with the sigma value. So we know that the KDE PDF p of x is equal to, remember it's the sum of Gaussians, so we're going to have g that is takes in an x and it's parameterized by 1, which is this first value, and 1, which is for sigma, plus the g of x, which is parameterized by 2, and that same sigma, plus g of x, with now the 5 and the sigma. And remember, this is the average, so we need to divide this by 3. And that is our p of x. Once again, I apologize, there's a bunch of x's in here. Just for explaining sake, this is the x value we're trying to find the probability of. And then this big X over here means the set of all of our samples. So this xi is just the ith sample in that set. But yeah, thank you.